In this section, we're going to be looking at trigonometry in right-angled triangles. Consider the right-angled triangle below. We can see the right angle just here. We know that the longest side of a right-angled triangle is called the hypotenuse. And when we label the triangle, we usually just call this HYP for short. Let's suppose we call this angle just here A. Compared to this angle, this side, away from the angle, is called the opposite. And when we label, we'll just call it OPP. The remaining side, the one that's next to the angle, but which isn't the hypotenuse, is called the adjacent. And when we label the triangle, we'll just call this ADJ. When doing this labeling, a certain amount of care needs to be taken. Let's explain why. Consider this right-angled triangle. We can see the right angle just here. This side is the hypotenuse. The longest side, remember, is always the hypotenuse. If this is our angle A, then this side would be opposite A, and this side would be adjacent to A. Adjacent next to the angle. However, if we call this angle B, this would be the opposite to B, and this one the adjacent to B. Notice how this one is next to the angle B. It's very important when you label your triangles that you think about each triangle individually. It's very easy to do examples where it's always this angle we're looking at, and then you write down this one's the opposite, and this one's the adjacent, and then when given this angle, just to label them the same way, and therefore your labeling would be incorrect. So treat every single triangle on its merit, and decide which side is the adjacent and which is the opposite compared to the angle which you are interested in. The hypotenuse, of course, is always the longest side, so is easy to identify. As we work through the examples on trigonometry, you'll see that we do this labeling process all the time. It's a crucial first step, so it's important that you can identify the hypotenuse, the opposite, and the adjacent. We need to make 3 definitions. Note that these are definitions. You need to remember them, and there is nothing here to understand. Every time I teach this topic, there's always some pupil who says, "I don't get it." In a sense, there is nothing here to get. We're about to make definitions. There's nothing more to understand here than to understand that your foot is called your foot. Consider this right-angled triangle. Let's suppose this is the angle A in which we're interested. We know the longest side is called the hypotenuse. Compared to A, this is the opposite, and this is the adjacent. We define the following. Sin A is equal to the length of the opposite divided by the length of the hypotenuse. This is called the sine of the angle A, but we just write sin A. Cos A is equal to the length of the adjacent divided by the length of the hypotenuse. This is called the cosine of the angle A, but we just write cos A. Finally, we have tan A, which is equal to the length of the opposite divided by the length of the adjacent. This is called the tangent of the angle A, but we just write tan A. As mentioned before, there is nothing to actually understand here. You just need to learn these definitions in the way that you've learnt, for example, your name. Sin A is the name given to the length of the opposite divided by the length of the hypotenuse. This is something that just simply needs to be learned. So here we have the definitions again. Sin A is equal to the opposite over the hypotenuse, cos A is the adjacent over the hypotenuse, and tan A the opposite over the adjacent. An example with actual numbers can help us remember this. So let's consider this right-angled triangle here. This is the 3, 4, 5 triangle, which you may know is right-angled from your work on Pythagoras' theorem. If we consider this angle here as angle A, we know the longest side is the hypotenuse. Compared to A, this side is the opposite, and this side here is the adjacent. Sin A is the length of the opposite over the length of the hypotenuse. Here this is 4 divided by 5. So sin A is 4/5. Cos A is the length of the adjacent divided by the length of the hypotenuse. Here the adjacent is 3, the hypotenuse is 5, so cos A is 3/5. Tan A is the length of the opposite divided by the length of the adjacent. Here the opposite is 4, and the adjacent is 3, so tan A is 4/3. Now if we consider this angle, the angle B, compared to this angle, the longest side is still the hypotenuse, but now this side is the opposite, and this one is the adjacent. Sin B is the opposite over the hypotenuse. The opposite is 3, the hypotenuse is 5, so sin B is 3/5. Cos B is the adjacent over the hypotenuse. The adjacent for B is 4, and the hypotenuse is 5, so cos B is 4/5. Tan B is the opposite over the adjacent. For B, the opposite is 3, and the adjacent is 4, so tan B is 3/4. For those of you who like to look a little deeper than just what you need to know to pass GCSE, consider the fact that sin B is 3/5, which is the same as cos A. Cos B is 4/5, which was the same as sin A. Tan B was 3/4, and tan A 4/3, in other words, the other way up. Looking at this triangle should help you understand why this is the case. And as I say, you wouldn't need to know this in order to do well at GCSE, but if you're considering further study, looking at this type of thing can help. So now let's look at these definitions and how we're going to remember them. We can summarize them using a mnemonic. Remember that mnemonics help you remember things. The mnemonic for trigonometry is so, ka, toa. Note the order of the letters in each part of the mnemonic. Look at so. Sine of the angle is equal to the opposite divided by the hypotenuse. Look at car. Cosine of the angle is equal to the adjacent divided by the hypotenuse. And for TOA, tangent of the angle is equal to the opposite divided by the adjacent. If we are given any two pieces of information in a right-angled triangle, we can solve the triangle. Solving the triangle means finding all unknown lengths and angles. If we have two sides, we can work out the angles. These are the two angles other than the right angle, which obviously we already know. If we have a side and an angle, we can work out the lengths of the other sides. Obviously we'd already know the other angle, as the angle sum of a triangle is 180 degrees. We will see how all of this fits together in the examples that follow.